Quick question. Which is bigger? The square root of 10 or 3.2? What even is something like pi or the square root of 2? These are called irrational numbers, and by the end of this video you'll know exactly what they are, how they're different from rational numbers, and how to compare them quickly. So what are irrational numbers? Rational versus irrational. A rational number is any number that can be written as a ratio of two integers. Now, if that sounded fancy, don't worry. An integer is just a whole number, positive, negative, or 0. So here are some examples of integers. 3, 0, 7, negative 42. Those are all integers. Now, when we say a ratio of two integers, we just mean a fraction where the top and the bottom are integers. So like 1 over 2, 3 over 4, 7, because that's 7 over 1. These are all integers on top of integers. So 1 is an integer, 2 is an integer, and then that makes a ratio when you put them on top of one another. So rational numbers can always be rewritten as fractions using integers. So 0.75 is equal to 3 over 4. Irrational numbers are different. An irrational number cannot be written as a ratio of two integers. That means you cannot express it exactly as a fraction. Its decimal goes on forever without repeating in a pattern. So here are some examples of irrational numbers. Pi. Pi is 3.14159 and so on. The square root of 2 is 1.4142 and so on. Square root of 3 and e. These are all irrational numbers. These decimals never end and they never repeat predictably. That's what makes them irrational. Here's a shortcut. Square roots are a huge clue. If you take the square root of a perfect square, you get a rational number. So the square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. Square root of 25 is 5. These are perfect squares. But if the number inside is not a perfect square, the square root of 2, or the square root of 7, or the square root of 10, then those numbers are irrational because they create messy decimals that never end cleanly. That's the same with cube roots sometimes. Like the square root of 8, or the cube root of 8, sorry, equals 2. But the cube root of 5, that's irrational. So this is how you compare these irrational numbers. You convert them to decimals. So let's go back to what we started with in the beginning. The square root of 10 and 3.2. Well, the square root of 10, we know that's somewhere close to 3 because it's close to the square root of 9. And the square root of 10 is 3.16 and so forth. Well, that means that 3.2 is greater than the square root of 10. So Let's also use we use nearby perfect squares to compare these numbers. Let's compare the square root of 50 and 8. What perfect squares are near 50? 49 and 64. 50 is in between there. The square root of 49 is 7. The square root of 64 is 8. So 50 is just a little bit bigger than 7. The square root of 50 is a little bit bigger than 7. So that means that the square root of 50 is less than 8. Another method is to square both sides. The square root of 15 versus the 4. So let's square both. That will give you 15, and that'll give you 16. Which one's greater? 16 is greater than 15. So that means that 4 is greater than the square root of 15. Only do this if both numbers are positive.